Hey, welcome back to the series. Until now, we have tested the application with test data. So we did not have any database configured so far. So I think it's time for us to configure MongoDB, which is our backend database. So let's go ahead and do it. So as you can see in this diagram, we have controller, service, and repository. And basically, the repository class is responsible for handling all the database related stuff. So let's go ahead and configure the MongoDB. So here is our application, and we have I think we need to install MongoDB and Mongoose as dependencies before we configure repository class. So let's go ahead and install MongoDB driver. Once MongoDB driver is installed, we need to install Mongoose as well. So Mongoose is a library which makes our MongoDB queries easier, and also we can define the schema as well for the MongoDB collections. So we have installed MongoDB and Mongoose, and the library versions are 5.7 and 7.3 respectively. And I'm going to create one folder called config. And I'm going to name the file name as dbconfig.js. You can name the file as you want. Since it's related to DB, I just named it as dbconfig.js. So the first thing we need to do is import Mongoose library. So once imported, we need to define two functions. So one function is to connect to the MongoDB instance. Another function is to disconnect. So let's define this. So we are going to add two functions. One function is to get connected to the database instance. Another function is to get disconnected. So, and we're going to export these two functions from this file so that if you import in any other file, we will be able to connect to a database instance. So let's import. Let's export with module.exports. Since there are two functions, you can actually export an object. So that object contains these two functions. So here is the connection, Mongoose connection code, where with connect function we will be able to connect to a database instance, and also we are listening to two events. One is open and one is error. Whenever we try to connect to database instance, whenever there is an error happens, we can listen to those events. And also whenever there is a close event, you can actually listen to that event with once, Mongoose once. And also if you can add your own logic here. So whenever there is a close, whenever there is a connection close, you can have your own logic there. And also right now we are just putting some console log statements. We are not putting any logic yet. So this is our DB configuration file. So we have two functions, one is connect and one is disconnect. And let's go ahead and see what is our MongoDB URL. So at this moment, we are trying to connect to local database instance, which is MongoDB, which is running on port 27017, and also it's a local host. So copy this and paste it here. Now this is our complete configuration file for our database. Now we have two functions, and we have put the URL as well, and we are listening to events as well. Whenever there is a connection open, whenever there is a connection close, we are listening to those events, and also we are having a console log statements there. Now our configuration file is completed, and let's go ahead and define the model. So here we need to define a model for our collection. So the first line is we need to import Mongoose library, obviously, And the second statement is we are actually defining a schema for our collection. So we have a collection called tasks. If you notice line number 14, we have a tasks collection, and for this collection these are the things that goes inside. For example, task, assignee, status, created date, updated date, created by, updated by. These are all the things that goes inside this collection. So each document contains this. So it is very important to define this kind of schema because the MongoDB is schema-less. So you can insert any document. In a document, you can insert any fields basically. So by defining schema like this, we are actually telling MongoDB or the server, hey, these are the things that you need to put in the document. Anything outside of these things or these fields, we have to throw the error. That doesn't go into that particular document. So that is the importance of defining a schema for your collection. So we have added description as well, and the timestamps, whenever you insert the created date, timestamps, created date and updated date is already created. So that is what the timestamps does at line number 12. So now we have defined a schema and we need to import that schema into the repository. Remember, the repository class is responsible for handling all the database related stuff. So first we need to import the task. Since we are exporting task from model, we need to import the task here. So let's import that. Let's give a correct path. Model task model dot, yep. So before that, we need to connect to the database instance before you query anything. So every class has a constructor. So whenever the class is instantiated, the constructor is the one which is called first. So we have to define that connect. We have to call this connect in the constructor so that whenever this class is instantiated, we are already connected to the database instance. Now we connect to database, and then by using task model, we will be able to query objects and create objects. So the first one, get tasks, will use find query to get all the objects, and the second one, create task.create task, will actually create the document in the tasks collection. So there are so many other functions as well, like insert many, insert one. You can find that in the MongoDB documentation. What are all the methods that you can use to insert data into MongoDB. So right now we are using task.create. So let's go ahead and start the application. Npm start. Okay. I don't think we have start command. So we need to run npm run dev so that our nodeman will listen to the files whenever there is a change happens. So I think we are using logger. Since we did not define any logger, we have to remove that logger. Instead of logger, we need to define console log statements. So in the next episodes, we are going to define a logger where our common logger file where you can console log with logger service. So I changed that to console.log. Let's see whether it runs or not. Still we have some issues going on. Okay, so we have passed some options in the Mongoose connect function. I don't think this particular driver is not supporting those options. Let's go ahead and comment those options. We will find out why these options are not supported in the future episodes, but right now we don't want to worry about all those. Let's comment these and let's start our application. Yep, now application is started. So let's see, let's go ahead and call this post method. So right now we are not able to, I think, let's see, let's find out whether we are able to save it or not. So let's give the command show collections. We have tasks. So the Mongoose has created tasks collection already. And let's see what we have in this tasks collection. Yep, we have some data here. And we have some data, and also so we have 4 objects in this collection right now. Let's go ahead and test the get call, whether we retrieve all these objects or not. So basically there is a problem with this code. I want you to understand. So that's why I created this without handling any promise, so that once I fix this, you will understand why we need that. So let's go ahead and test the get call. So once we hit this get call, we are getting this some error, circular JSON structure. So first of all, we need to define whenever we send the data back, it's a JSON data. It's not actual any HTML or any other text. Since it's a JSON data, the first thing we need to change is we need to change that send from send to JSON, so that Express.js will automatically converts the response to JSON object and sends the JSON object. So we still have an issue. Let's find out what is the issue. So the issue here is, since we are connecting to the MongoDB instance, and there is some latency. Whenever we connect to database, there is some latency. It's a promise. So you cannot get the data immediately. It's a callback and it's a promise. You need to wait. You need to wait until you receive the data from the MongoDB instance. So that's why we have to add async await function. So we just need to add async to the function, and you need to add await to the statement, so that we wait until we receive the data from the MongoDB, and then we send the tasks to the client. So now we don't have the error. The error goes away. Now let's see what is the issue. Why we are not able to retrieve all the documents. Let's find it out why. So let's go to the to-dos routes. So this is good. This is good. So here we have async and await function. Let's find out whether we have the data here. So let's put the console log statement here and hit this again. Yes, we have the data. We received the data from MongoDB, and we are sending the data back to the service. And the service, you don't need to define async await here, because we don't have the logic here. So the return statement will return the promise instead of the actual code. So go to the to-dos route. Now, since it received the promise, you have to define this async await. So let's define async to the function, and let's add await to the statement here as well. Okay, we have added async to the function, and then let's add a separate line here. to retrieve the tasks from the controller. Copy this. So right now, so since we are receiving a promise, we have to put await and the statement and the statement beside it, and then we need to send the tasks in the response.json. Now it should work. Yes, now we are retrieving all the objects right now. So basically, whenever you connect to the database and get the data from the database, there is a latency involved in it. So it's going to be a promise. You don't get the data instantly like we have in the test data. So that's why we need to have that. So since I think we don't have the logic here. I mean, you can remove async await from here because it returns the promise. So if you are dealing with the logic, or if you are adding any logic on top of receiving the data from MongoDB, then you can put await async in the repository, and you can just manipulate the data and send the data. Otherwise, you can just do the return. The return will return the promise, and you can put async await in the routes instead of in the repository if you do not have the logic in the repository. So let's go ahead and do the same thing in the post as well. So let's add the async to the function and await to the statement, and also change that send to JSON. So let us test the post call. Yep. So now the post call also returns the data. So it returns the object which is inserted recently. So you can see the version -v in the object as well. Let's hit the get call so that whether we will validate whether this object is already there or not. Yes, we have this object. So there were 4 objects. Now the 5th object is inserted right now. So now the post call and get call working fine. Let's have 2 separate calls here. Let's create another tab and put the post call here. Let's copy the body and paste it here. So let's change the assignee to user3, created by user3 and updated by user3, so that we will see, we will notify. Okay, the URL, we need to change the tasks to task. Let's hit this. Now we have created another object. Let's go ahead and hit that get call, and we can notice that user3 object is already inserted here. Okay, now we have defined get call and post call. Let's go ahead and complete the delete call and put call. Yeah, first thing we have to do is we need a way to read this variable called ID. So if you notice the URL, in the URL there is a colon ID. That's a route parameter. So we need to read that route parameter. Let's find out how we can read that route parameter. Let's change this to from send to JSON and put the result here. And now So we can read the route parameter through request.params dot whatever the name that is given there. So the name given here is ID. So you have to read by request.params.id. So that is how you read the route parameter in the URL. So copy this and pass the ID as a parameter, and let's go to the service class. Now go to the now we are in the repository. So here there are a number of methods where you can delete an object in the MongoDB collection. So the method that we are using right now is find by ID and delete. Since we are passing ID in the route parameter, so we need to find a document or we need to find an object in the document by ID. So all the objects, all the documents has an ID field. So we just need to pass that ID like this. So we are using find by ID and delete, and let's go ahead and test it out. Now through get call, let's take this ID from the collection and pass it in the route parameter. Yep. So now let's send this. Yes. So if the object is deleted, if the document is deleted, so the deleted document, you will receive a deleted document as a response. If not, you will receive a response null. So let's test this one as well, the other object. So we are deleting the object which has user3. Now let's hit this and there is no user3 object or document here. So the delete call is working fine, and if you fire a delete call again, you will receive a null because the document is already deleted. So there is no document to be deleted yet. So that's why you will receive a null. Now we have only one document in the database. So now what we are going to do, we are going to use the same request.params ID in the put call as well. So in the update put call, so we are receiving a ID in the route parameter, and also we are receiving a body as well. So ID to find out the document, and the body to update any fields in the document. So let's change. Let's add the async to the function, and also change that send function to JSON, and let's add await to the statement, update task statement. Since update task will have ID and the body, so we need to pass these two. We need to pass two parameters in the method call, update method call. Yeah, we need to change that delete task to update task here. Let's change this and go to this function. Since we are passing two parameters, we just need to add another parameter, task. Same to the service class. Add the task here. So I mean, we are not adding much logic to the service classes and controller classes here, but in the real world application, we might need to add a lot of logic. That's why we are maintaining separate service and repository classes for the maintainability. even though even though you feel redundant, it is very important to have that proper structure. Okay, now we are updating we are using find by ID and update. So we are finding by ID and we are updating the status. So this find by ID and update will have two objects. One is you need to pass by ID how you find the document, and the second object will have what are the parameters that you are going to update in the document. You can put as many parameters as you want. For example, I am actually doing I'm updating two things here. One is status and another is updated by. Okay, now we have only one document. Now go ahead and update this document. So you need to pass that ID in the route parameter, and let's change the status to completed from to do, and updated by, let's change that updated by to user 2, and let's test this thing out. As you can see, the status is changed and updated by is changed. So that is how you update the document. And also there are, you can update, sometimes you might need to update only one field, sometimes you might need to update the whole object. So there are certain functions in the MongoDB documentation where you can find. Sometimes, even if you can put if conditions like this, and you can update based on the if conditions. For example, if the status is present, then you update only status. If the created by is present, then you update the created by, like that in the if conditions. But there are so many other options where you can use to update particular document. You can find that in the MongoDB documentation. Now we have completed all the to-dos route CRUD operations. So I have created multiple documents with a post call, and I have created multiple documents by putting different data. For example, right now I'm creating an object with assignee user2, and also I'm creating an object created by user3, so that for the history, when we test the history call, it will be useful. So as you can see, the history call will take the parameter called user ID. Now I'm going to add async function to the function, and also I'm going to change that send to JSON. You need to pass request params user ID. Since we are using user ID as a route parameter, you need to read it to request params and pass as a parameter. So remove this and change that to JSON as well. Go to the list task, and the list task will take the username as a parameter, and go to the repository. So in this repository, we need to, since we are not using any separate collection, so we are using the same tasks collection. So let's import the task collection in the repository, in the task history repository class as well. But in the real world, you need to define your own collections, history collection. You can have your own history collection, and you update whenever you create an object you update the history collection as well. But right now we don't want to do it because it will get longer and longer if we keep on doing that. So let's use the same tasks collection to find out by created by. Since every time you create an object, there is a created by. So we are finding a document by that particular field, which is called created by. Now, when you have, let's copy this URL and let's create another tab and for the history. So let's remove the task and let's put history here. And also you need to pass the parameter, route parameter, which is user1. Now, if you look at it, you will only receive documents which has created by user1. And let's change that user2 and send it again. And now you receive an objects that are created by user2. Change that to user3. Again, you will receive all the objects that is created by user3. Now let's test the archive call as well. So I'm not going to. It's a delete call. Whenever this call is invoked, we have to change the status from. We have to change the status in the document to archived. Since we have defined the route handlers, chainable route handlers here. I want to change something here. So instead of passing user ID, I want to define that route parameter as ID so that that ID can be used as user ID in the get call. The same ID can be used as ID in the delete call. So I would like to change that. So that is the advantage of having a route parameters instead of query strings. So in the route parameters, you have to define the name of the variable in the code. In the query strings, you have to change in the URL as well if you want to change anything, any variable name. So I changed that from user ID to ID, and I'm using the same ID to both calls, get call and delete call. Let's go ahead archive task and go to the service and go to the repository. Here we need to do the same thing as we did for the update call. All we need to do is find by ID and change the status to archived. So we don't have to take any body, because all we need to change whenever you invoke the delete call in the history, all we are going to do is we are changing the status of the document to archived. So since it's a static, you can directly pass archived in the status object, in the second object. So this archived status doesn't have to come from in the call post parameters. Now let's test out this delete call. History, and I'm going to retrieve and get call and get some ID. Let's take the ID. So I'm going to copy this ID and pass this ID as a route parameter. So for this ID, the status will be changed to archived. So let's find it out. As you can see, the status is changed to archived. So that is how you update anything. It's the same as update call in the to-dos history, but you are not taking any data from the call itself, since it's a delete call. So now task history is completed and to-dos is completed. Now we are going to do detail call, so detail routes. So here all we need to do is add the async function to each function. Let's go ahead and add it. So here also, if you notice, here also we are actually using chainable route handlers. Now add a statement with await. And instead of 1, 2, 3, I'm just passing route parameter ID with request params.id. And change that send to JSON. Now I'm going to copy this and paste it in the below two functions. So edit task will have two parameters. I'm going to add second parameter with request.body. Now we have defined the router, and let's go ahead and change the edit task. Let's fix something here. So now we need to import the same task function, because we are actually changing the task collection. We are still changing this task collection, so we need to import the task collection and write queries based on the task model. Now since we are finding by ID, you can just change that to ID. Now detail is completed. Same thing, edit task will take the ID as a parameter and also body as a task. So remove task will find and delete. Now we have defined all the functions and all the repositories are updated, and the only thing remaining here now is we just need to test this detail URLs. Copy this ID and pass this ID as a route parameter. Yep, detail call is working fine. Copy this and create another tab. I want to test the delete call. Okay, something is wrong. something is going on with this delete call. Let's see what is it. Okay, in the controller we have defined task. So I think we have wrongly defined methods here. Let's change that. Let's remove the task from here. Let's test it now. Now the delete call is also working fine. In the same way, we can test the update call as well. And so finally, I'm going to change one thing in the structure of our application. I'm going to push all our source folders into source folder. So that way it is very easy to understand our code. Otherwise, if you keep on adding folders, your folder structure will get bigger and bigger. It's very difficult to navigate through your application. So let's test this thing out. Since we changed the structure so that a get call is working. That means your application is also working. So thank you for watching. I know it's a big video. Thank you for watching till the end. Don't forget to subscribe. In the future episodes, we're going to see more complicated topics, how to build for production, and there are a lot of things we will explore.